Equivalent fractions, which you multiply to the denominator, you must also multiply to the numerator. And multiplying by 1 won't change the value of the fraction. So our first fraction here, 3y divided by 16x squared, is supposed to be equivalent to a new fraction where the denominator is 96x cubed y squared. We'll first look to see if the 16x squared exists in this new denominator. And the 16x squared is being multiplied by 6 and an x and a y squared. So our original 16x squared to turn into 96 had to get multiplied by 6, also multiplied by another x, and this y squared. So that's what we need to do to the numerator. We'll take the original 3y and multiply it by the 6 and the x and the y squared. So our original fraction 3y over 16x squared is equal to 18x y cubed over 96x cubed y squared. Let's look at another example. This one's a little bit more complicated because of the addition and subtraction signs. That's when we need to factor. That's when we need to use parentheses. The first rule in factoring is take out what's common. In this denominator there's a 3 and an x common, and what's left is 3x minus the all-important 1. 1 because I take this 3x and multiply it to 1 to get my 3x. So make sure that if we're going to factor this next denominator, we have to follow the rules again, which is always look for something common first. I notice they're all divisible by 3 and by x. Taking out what's common and showing you what's left would give me a 3x squared plus 5x minus 2. Now in order to factor, you want to try and factor completely. Let's factor again. So if you didn't get a lot of practice factoring from the last chapter, we get to try it some more. Breaking down the first term, we'll use a 3x and an x. Breaking down the last term, we're going to use a 2 and a 1. But I'm going to note what I already had was a 3 with a 1, so I'm going to try the 1 here and 2 here and see if that works. That would give me a 1x and a 6x, and the signs are supposed to be different, which means I'm going to subtract, so in fact I could get a 5. I want that 5 to be positive, so I'll add the 2 and subtract the 1. Now in comparing this denominator with the original denominator, we notice there's one new, and that factor is the x plus 2. So if I multiply this denominator by x plus 2, I would have to multiply this numerator by x plus 2, and that way it would stay equal, be equivalent. So our new numerator, using the distributive property, would be 5x plus 10.